On a node in packet switching communication network, a network scheduler, also called packet scheduler, is an arbiter program that manages the sequence of network packets in the transmit and receive queues of the network interface controller, which is a circular data buffer. There are several network schedulers available for the different operating system kernels that implement many of the existing network scheduling algorithms. The network scheduler logic decides, in a way similar to statistical multiplexes, which network packet to forward next from the buffer. The buffer works as a queuing system, storing the network packets temporarily until they are transmitted. The buffer space may be divided into different queues, with each of them holding the packets of one flow according to configured packet classification rules. For example, packets can be divided into flows by their source and destination IP addresses. Network scheduling algorithms and their associated settings determine how the network scheduler manages the buffer. Also, network schedulers are enabling accomplishment of the active queue management and traffic shaping. Network scheduling algorithms. In the course of time, several network scheduling algorithms have been developed. Each of the scheduling algorithms used internally for these queuing disciplines provides specific reordering or dropping of network packets inside various transmit or receive buffers. Queuing disciplines are commonly used as attempts to compensate for various networking conditions, like reducing the latency for certain classes of network packets, and are generally used as part of the quality of service measures. Examples of algorithms suitable for managing network traffic include AVQ, CBQ discipline, choke is a variant of red, codal and fair, flowqueue codal, credit-based fair queuing, DRR and DWRR, implementation e.g., written by Patrick Mahadi for the Linux kernel and published under the GNU General Public License, GCRA, HFF, HFSC, HTB, QFQ, FQ and WFQ, FIFO, PKT_shed, FQ, FairQ packet scheduler, NETEM network emulator, Pi, RED as well as ARED, RRED and WRED, RR and WRR, SFB as well as RSFB, SFQ, TBF, TEQL. Several of the above have been implemented as Linux kernel modules and are freely available. Buffer bloat. Buffer bloat is a phenomenon in packet switch networks generally, in which excess buffering of packets causes high latency and packet delay variation, as well as reducing the overall network throughput. When a router device is configured to use excessively large buffers, even very high-speed networks can become practically unusable for many interactive applications like voice calls, chat, and even web surfing. The Codal algorithm attempts to reduce this problem by improving upon the RED algorithm. Codal is less prone to the effects of buffer bloat than the common tail drop disciplines. Terminology: active queue management, the employment of an arbiter program. Network traffic control, an umbrella term for all measures aimed at the control of traffic. Traffic shaping, a form of AQM, where the available bandwidth is being limited to match certain use cases. Link sharing, this term is used when more individuals or customers share the same internet connection. Traffic prioritizing, a form of AQM that selectively prioritizes certain network packets. TCP turbo, by prioritizing ACK packets on the upload, a slowdown of the download rate of a TCP connection is prevented. Bandwidth management, the management of the available bandwidth. Implementations: Linux kernel as the default queuing discipline. Linux kernel uses a FIFO implementation called FIFO_fast. Although systemed since its version 217 changes the default queuing discipline to FQ_codal. Linux kernel's network scheduler is an integral part of the Linux network stack and arbiters the ring buffers of all NICs. By working on the layer 2 of the OSI model and handling Ethernet frames, It manages the transmit and receive buffers of all NICs installed in a computer. The user space programs ifconfig and IP enable system administrators to configure the buffer sizes txqln and rxqln for each device, separately, with their units being number of Ethernet frames regardless of their size. The Linux kernel's network stack contains several other buffers, which are not managed by the network scheduler. The overall size of all buffers has been the point of critique by the buffer Bloat project, which provided a partial solution with Shedule that has been primarily tested in OpenT. Another network scheduler is being developed as part of NetFilter and NFTables. buffer.altq is the implementation of a network scheduler for BSDs.